In this video, I am going to review radical multiplication, in other words, multiplying square roots and also higher power roots. With multiplication, with addition and subtraction, it was a little stricter. You add and subtract what's in front of radicals if the radicals are the same. But with multiplication, these do not have to match. They can be different. And what you do is radicals get multiplied together. So in this example, radical 3 times radical 6 would be radical 18. Then you would look at what you have and you would see if you can take it further and by breaking that down into smaller parts. So the square root of 18 is the same thing as 9 times 2. Remember, you're always looking for two numbers where one of the numbers is a perfect square. And sometimes remember also you have more than one option of pairs of numbers you can use. Like, for example, 32 is 8 times 4 and 16 times 2. But in a previous video, I went over how you always have to make sure if there's more than one pair of numbers or more than one pair of factors that has a perfect square, you have to take the biggest. So for 18, we have 9 times 2 and 6 times 3. 6 times 3 will not work, but 9 times 2 will. The square root of 9 is 3, and the 2 stays underneath next to it. Now, what would happen if we had something like the square root of 80 times 2 square root 45? Well, you can click on the explanation and let's see how I'm looking at how they're doing it moving forward. So there's a couple ways you could do this because 80 is so big. Some people will actually break these down individually before they multiply. So I'm going to do it that way just because that's how Alex is doing it. So what they do here is they take 80 and they make it 16 times 5. And then they know that 16 is 4 and the 5 stays underneath. For 45, I'm going to keep the 2. That comes from here. I know that 45 is 9 times 5 because 9 times 5 is 45 and 9 is a perfect square. So the 9 is going to become a 3 and go with the 2 on the outside to give us a 6. So again, the 9 becomes a 3 and the 2 and the 3 get multiplied to give us 6 square root 5. Now with radicals, again, if this was addition, this would be perfect. If this had said plus or minus, I could totally combine them because they both have a radical 5. If it was addition, the answer here would be 10 radical 5. But with multiplication, you always multiply what's in front of the radicals, which would be 24. 6 times 4 is 24. And you multiply what's underneath, and you get 25. So you end up with 24 square root 25. Now you always want to look at the square root and see if there's anything else that can be done. In this case, I know that the square root of 25 is 5. So I no longer have a square root here, and I end up with the final answer of 24 times 5 because the square root of 25 is 5. And 24 times 5 is 120. Now that won't always happen. Another thing I can remind you of, one of the reasons this happens is whenever you multiply a square root by itself, so the square root of 5 times the square root of 5 is always regular 5. The square root of 3 times the square root of 3 is just 3. Multiplying a square root by itself leaves you with whatever's underneath every single time. Now you don't have to remember that yet. All you have to do is remember to multiply, and then you'll see that once you take the square root, that the square root disappears. Let me see, I'm just taking a peek to see what else is here. Let's jump down to number 3 here. So here we have number 3, we have variables and numbers. When the numbers are small like this, I typically tend to just put it together first. I find it a little easier. The only reason I broke down number 2 before I multiplied is because the numbers were pretty large, but these numbers 2 and 10 are not that big. Also, 2 and 10 will not break down any smaller. So what I would personally do is multiply what's underneath together. 2 times 10 is 20. y to the 7th. Now, why is it y to the 7th? Because when you multiply with variables, the exponents get added. y5 times y2 is y to the 7. Now that I've multiplied this and I end up here, I want to look at this and see what I could do to it to maybe simplify it further. I know that 20 is 4 times 5. So 20 can be rewritten as 2 with a 5 under the square root still. I also know that I can take out some y's because I have 7 y's and an index of 2. So exponent divided by index, 7 divided by 2. It goes in 3 times with a remainder of 1. So I can take out y to the 3rd power and put back under a single y variable. And again, just like this is sort of combining everything we've been learning. So you're able to break it down after, or you're able to break it down before, but the idea is that radicals can get multiplied together. And if there's numbers, like in this example here, numbers in front get multiplied and radicals get multiplied, which is very different from addition and subtraction. We're going to take a look at one more example here for multiplication. I do want to mention that if the index is different, like you're going to get some problems where there'll be maybe an index of 4 instead of like a 2 inside. You can multiply as long as the index matches, and the way you break it down is slightly different, but feel free to reach out and ask questions if you have trouble on any of the higher root problems. I would be more than happy to do some more examples. Now I'm going to take a look at how you would apply the distributive property, which is still multiplication. Because remember the distributive property, when you have something in front of parentheses and you put it in the parentheses, you multiply it in. So distribution is a form of multiplication, and we will see how that applies to square roots and higher root problems. So I have 5 square root of 15 minus 3, and I have a square root of 5 on the outside. That square root of 5 needs to get multiplied to both of the terms on the inside. So here, if you need to, you can put a 1 in front of the square root of 5. Some people need to see that visually, but there is technically a 1 here. So when you multiply these first two terms together, the 5 is going to stay a 5 in the front because 1 times 5 is 5. And then the 15 and the 5 that are underneath can get multiplied together to give you 75. Minus, because there's a minus here. Now, when you do the second multiplication, you have a square root times a non-square root. You're allowed to do that. You just put them next to each other. It looks like this. The square root of 5 times 3 is just 3 square root of 5. Just like if I said to you, what is x times 2? I'll write it over here. X times 2 is just 2x. We put the number in front of the letter. So the square root of 5 times 3 is just 3 square root of 5. You just attach them. Now, can I combine this through subtraction the way it is? No, I cannot, because the 75 and the 5 do not match, and it is a subtraction problem. So I would look at each term. This one I know nothing can be done to it, but over here I can do something. So I get 5. 75 is 25 and 3. I then have a 5 on the outside, and I'm going to put another 5 next to this because the square root of 25 is 5. The 3 stays underneath. 5 times 5 now is 25 square root 3 minus 3 square root 5. And all of that work I did to break down this first square root, and I now can't even subtract them because these do not match. One is a square root of 3 and one is a square root of 5. You can only combine these through addition and subtraction if the square roots match, but they don't. So this would be my final answer. And then the very last thing for this video is you can also do special products, like foiling. So give me a minute to write this out. Where you have 2 terms times 2 terms. And they call this a special case. I don't love when they call it a special case because I just want to make sure I had the right thing here. They call it conjugates. There's a shortcut they're going to show you, but I say you just do this like you would do FOILing normally. So 3 square root of x is going to get multiplied, I'm going to do one arrow at a time, to 3 square root of x. And when you multiply these two terms, you do the 3 times the 3, which is 9, and the x times the x, which is x squared. And I'm going to leave that for a minute. Then I'm going to draw my next arrow. 3 square root of x and the square root of 2. So there isn't anything in front of the square root here to go with the 3, so the 3 just gets carried down as a minus 3. Technically there's a 1 here, so you can put it in if you'd like. 3 and negative 1 is just negative 3, and x and 2 can get multiplied together to leave you with 2x. Then I'm going to go underneath with my arrows. Here, there's a 1 here. 3 times 1 is just 3. 2 times x is 2x. And then my last arrow, my last multiplication, positive 1 and negative 1 is negative 1 square root 4. Now there's quite a few things we can do here. The negative 3 square root 2x and the 3 square root 2x, this is the shortcut. This will always happen when they're conjugates. So if you see the word conjugates, you're going to notice this common theme. But I still think that it's a good idea for you to multiply all 4 options, in this case all 4 sets of terms, and then just be happy when the middle terms disappear. Now 9 and the x squared, the 9 is going to stay there, but the square root of x squared is just x, because remember a couple things. Anytime you have a square root and a squared, they're inverses of each other. They cancel each other out. Also, if you think about it like exponent divided by index, or 2 divided by 2, you get 1 remainder 0, which means you can take out an x and there are no x's left over to go back underneath. And then over here I have minus 2. And the reason I have minus 2 is because the square root of 4 is 2. And there's a 1 here already. So my final answer for this problem is 9x minus 2. So FOILing is also an option when you're dealing with these types of problems, as well as the distributive property. It's kind of the same technique. If you need any additional assistance with the multiplication, again, let me know. Thank you so much.